Snell's law itself is easy, and the only way to make a difficult Snell's law problem is actually to make it all about geometry.
Please don't.
You know, I have a problem making something all about geometry, so the typical Snell's law problem that would be reasonable for an exam, this one has appeared on an exam, and so as the next one would be to take a Snell's law problem and put a little bit of geometry, followed by Snell, followed by a little bit of geometry. Okay? So that's what this is. So here we have it. Shown in the figure below is a water glass at two different moments. In the first moment, which is on the left, the water glass is empty and the light ray strikes the bottom corner as shown. So it just barely becomes above the edge of the glass on the left, and it hits the right-hand edge of the glass at the bottom corner on the right. In the second moment, the glass has been filled with water, and as a result, the light ray bends when it is incident on the water, and it doesn't go straight, but it becomes what? Closer to the normal or further from the normal? Closer to the normal because it enters a higher index of refraction than what it left. So this one is calculate everything. First I need to calculate theta 1. How would I calculate theta 1?
Tangent.
Correct. This is theta 1, so this is also theta 1. 8 centimeters down there, 15 centimeters over there, and therefore tan theta 1 is 8 over 15, leading to theta 1 equals what? 28 degrees? Is that what I heard?
Yep, 28.
Okay. In the second moment, it is bent in accordance with Snell's law. What does Snell's law say? N1 is 1 for air. For water, N is
1.33.
Not Tesla.
And what's the third thing we want to calculate? What's X? Okay. So that's just geometry. There's X, which is still 15, and now it's theta 2 in here, and so tan theta 2 is what? So X is? How much?
Okay, physics.
Ta-da! So now you can start measuring.
Yes.
Okay.
$5,000 cash. Yeah.
Okay. So, here we go. As shown in the figure below, a small boy has lost his toy at the bottom of a pool. When he shines his flashlight as shown,
Oh yeah, I remember that one.
Okay? So the flashlight is 1 meter above the surface of the water. The pool is 1.5 meters deep. The light strikes the surface of the water 3 meters away from where the flashlight is. Okay? Therefore, we need to figure out where the toy is. And so it's broken into 3 parts. What's the angle of incidence? Theta 1. What is the angle of refraction? Theta 2. And then what is the distance from the water's edge? X to the lost toy. Everybody follow?
Yeah.
I think your book has a problem like this with a police officer who keys
Yeah.
or a problem.
Yeah.
that happen? Oh, my keys are in the bottom of the pool.
Dead body. Yeah, it is.
Do you remember for exam 1 last semester when we had a problem where you were racing your car against the train?
Yeah. Oh, yeah.
That was a problem from an exam, and the first draft of it, you were racing it to cut across the tracks ahead of the train. And my co-teacher at the time said, "You can't do that! You're telling them to do this dangerous thing!" No, I'm not. Do it. Whatever. Okay.
No, you can't.
Yeah, right? Can we do it? Can we do it? Oh, no. Do it. You got one. Dude, we got a pen. Fuck. How good, man. That was so intense. It's like, could be a show at it.
Now, Snell's law always measures the angle as compared to the normal. So I'll draw normal on this diagram. And theta 1 is there. If that's theta 1, what's this? 90 minus theta 1. Yes, 90 minus theta 1, what's this? Theta 1. Therefore, how would I find theta 1? How would I find theta 1?
And theta 1 is 3 over 1.
Yeah, so 3 over 1. Was it X over Y over X? Opposite over J.
Opposite over J.
So it's Y over X, yeah.
Okay, so what do I get?
72.
It's all right.
Okay. Snell's law. So what's theta 2?
45.5.
How much?
46.
Okay. I'm going to test you for thinking instead of calculating. Round 46 to 45. How far from the edge of the pool? 4.5. Very good. Because if the angle is 45, then the two legs of the triangle are the same size. The vertical is 1.5, the horizontal is 1.5, and then add 1.5 to the 3, and you got 4.5. Okay? We're going to get slightly bigger than 4.5 if we use 46 degrees, and that's because we're going to say, I'll make this distance here little d, and I'm going to say that tan theta 2 is little d over how much? 1.5. So that little d is how much?
10.
1.5682.
Well, yeah. So what's it come out to? 1.52.
Looking for
Okay. So what's that? X is this distance from here to there. So X is bigger than D by 3 meters. So yes, 4.5 coming in our head, which should have been awfully close, is indeed awfully close.
Please get this problem.
Reasonable? Okay, move down a little bit. Aha! Look at that one.
Oh.
Okay. Shown in the figure below is a medium with n equals 1.3. No, sorry. Shown below is a light ray traveling in a medium with n equals 1.3 that enters a medium with n equals 1.2 and another medium with n equals 1.1. If the angle theta 1 is 50 degrees, then calculate a few things. Okay?
Not bad. Just use snail. Whole bunch of snail.
So here we go.
Hell's Law.
Okay, so the first one is 1.3 sine of what?
50.
Where?
Equals
1.2 sine theta 2.
So theta 2 is how much?
56.
56.
And then we do the same thing.
Okay? Then I'm going to do what's theta 3? 65. Now, drawn on the figure over here, 50 degrees, a little bit more than 45. Then I need to come out even bigger than 50. I'm exaggerating a little bit. At 56. Then I need to come out bigger than 56. So does everybody follow that that's what's happening to the light ray?
Yes.
Okay? Now, I want to ask you a question. If I keep doing this, what will eventually happen to that light ray?
By now.
At some point. It's going to turn around and go up, because at one of these interfaces, what's going to happen at one of the interfaces? Eventually. Total internal reflection. How do we decide what makes for total internal reflection? Critical angle. Critical angle is defined by what?
90 degrees.
Yeah, the outgoing angle is 90 degrees. Because actually if it's 90 degrees, it didn't go out. It stayed in, and then rather than refracting, it reflects. So the critical angle is the angle beyond which you can only internally reflect. You cannot leave the medium and still follow Snell's law. So if I took this lowest medium, this 1.1 down here, could you tell me how I could find the critical angle compared to, let's say, an n = 1 material on the south side? How would I find that? 1.1 sine theta critical is 1 sine of 90 is 1, so theta critical is how much? How much? Give me an angle.
65 degrees.
Is it 65?
Wow, no.
What's it?
About.
Yeah, it is 65. Whoa.
Ah!
What?
That's awesome.
So if that 1.1 is followed by air, what's going to happen to this light ray?
It will internally reflect.
It's going to reflect rather than refract. Then, after reflecting at the bottom, what happens next?
Goes back out.
It comes back out, and this ray actually, headed from down, bends and comes upward. So if that